you got to show how it benefits your end customer. And so if it's, removing a key barrier to obsolescence, if it's a reduction in cost, if it's an improved lead time, it's really relating it back once again to just, business 101, which is bring value to the customer. So I think what we've been able to do is build trust, connect it to value, and then demonstrate through performance that we can bring technology to the defense sector.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Matt Malone, President and COO at Graham Corporation. Matt, thanks for chatting with me today.
Absolute pleasure. Thanks for having me.
You bet. Well, it's been a journey. I love your story. I think the listeners are going to enjoy it. Why don't you kind of give a roadmap of how you got to be the president at Graham Corporation?
Yeah, so it starts back to a young kid. I am passionate about mechanical engineering, went to Penn State. And after went through the leadership development program at General Electric, worked there on locomotives actually for about 7 years after traveling the world, basically fighting problems with locomotives for key customers. And I was out at a ski trip in Colorado and founded Barber-Nichols, at which point I said, man, I would really love to join this business. Had the opportunity to interface with Dan Thoren, who is the current president at Barber-Nichols. And about a year later, I finally decided to join the team after what felt like it was going to be a career at GE. Immediately stepping in, there was a huge need, and that was to design rocket engine turbopumps for key customers. You can still name them today. They're the same players, but we had originally designed the Falcon rocket pumps for, Elon Musk and specifically for SpaceX. That evolved into a ton of work, which needed a leader. So I led that portion of the business for about 2 years, and then needed a key leader on the operational side, mostly on the defense platforms, which I had no background in. Name was tapped, kind of the similar story, and became an owner of the business at that point, putting money on the table because I love skin in the game and I'm an entrepreneur. And the journey was kind of set from there. The business today is made up of about 70% defense work, mostly on maritime systems. And in 2021, we sold the business to Graham Corporation, which is a public business in upstate New York. After leading the business for the last 4 years at Barber-Nichols, was tapped on the shoulder to take the next step, which was current role, President and COO at Graham, which will transform into President and CEO in June. So long story, but mechanical engineering and now business leader.
So how is that? I see this every once in a while, some larger corporations that enter at a, engineer level, maybe a, program director type of thing, and then scaled all the way to the top. How has that journey been?
Yeah, it's been fantastic. The thing that I would describe that's most important is when you have that engineering background, but yet you have a relatable enthusiast or optimist sort of personality, you tend to be able to connect with the people on one side, but also have an appreciation for the physics on the other side. And when you're designing mission critical systems, whether it's for defense, medical, whatever it might be, you have the ability to understand not only the technology, but how it relates to risk identification and mitigation, efficient problem solving, et cetera, et cetera. So those things become really paramount in, business strategy and product road mapping. So really simple kind of transition for me in theory, just bigger and larger or longer scope.
Oh, well, that's fantastic. Well, then talk us a little bit through, what does Graham Corporation do? What do, Barber-Nichols, you came from before that. Give us a sense of, is it just the rockets or, you said Navy systems? What are the technologies and capabilities you're bringing to bear?
Yeah, so Graham Corporation focuses on quite a few platforms, but the business was founded many decades ago on actually vacuum and heat transfer systems, mostly for the energy and chemical product lines. Things that includes is the main extraction of vacuum on like the top of a distillation tower that allows for the decomposition of, the different fluids coming out of the ground. And so you'd have at the bottom essentially tar for roads and at the top, refined fuels for other avenues. That has made Graham have about $1 billion install base. The challenge with it is it's very cyclical in nature, just like energy. And so the defense basis of the business was really pioneered in the mid 2000s. And the focus of it became utilizing the knowledge base on vacuum and heat transfer systems on submarines specifically. Today, Graham manufactures the main condenser, the steam condenser, for the Columbia-class submarine, as well as the Ford-class carriers, and a few other small fabrications that go inside. On the Barber-Nichols portfolio side, it's a range of rotating machines, everywhere from turbo pumps, which supply the fuel to the main combustion chamber on rockets, to submarines, which of course have what's called an air turbine pump, which is what launches the torpedo. So on the defense sector at Barber-Nichols, most specifically, we're making, I'd say, the power and brains in the torpedo itself. We're making the air turbine pump, which is what launches the torpedo out of the submarine. And then we're doing quite a few auxiliary items, mostly around rotating machines for thermal management. So on radar platforms, cooling the radar itself, and laser platforms.
That's great. And so what a transition, to not be in the defense. And then you said you jumped into that. Was there a moment in your career that was pivotal in your perspective of, man, I'm doing something that makes a difference?
Great question. I had no background in defense prior to actually not even Barber-Nichols. I wouldn't say I got a huge appreciation even when first joining, because I was designing rocket engine turbopumps. When I had the opportunity to become the program management leader, what I quickly realized was about 10% of our business was folks that had actually been in active combat. And after talking to them is when it really sparked the connection for me. Just sitting in a room and hearing the stories about how important X asset was at X time and leader Y giving this really critical piece of information at a very tactical moment really formed an insurgence for me to get engaged in the defense industry. Since then, it's really expanded well beyond that. Now seeing, torpedo practice missions and being on submarines at commissioning and really understanding the perspective of the warfighter has changed the perspective. So today, it started off as a small understanding through our employee base, and it's really merged into seeing it firsthand.
And it's so cool to have a mission aligned with, what you value, and it really changes. Have you seen that, kind of mission alignment and being able to point to the end user, the warfighter, help you on your leadership side within the company?
Yeah, it's 100%. We have a very clear mission with a few programs. And I would say what has most grounded that is the feedback from the U.S. Navy specifically. So we've had several rear admirals come to Barber-Nichols and actually explain the criticality of the product to our entire employee base, which immediately is a very grounding conversation. It brings importance, and it also extracts a level of detail for the employees that you can't articulate without knowing how the bigger chessboard is laid out. So for me, it's really been extracting the strengths of the different team members and aligning them to that greater mission, as you mentioned.
What have been the biggest challenges from leadership in this perspective, as you've made these transitions and continue to scale?
Yeah. So if you break up the portfolio of the business, you can think commercial on one hand and defense on the other. And the common sort of stereotypes that apply to each. So if you're thinking about space innovation, it's the fastest moving, most creative, build it, fail it, test it, fix it, sort of this really iterative approach. And then you have these same employees that you're trying to convince to work in a very slow moving set technical data package environment. And those two just clash. And so the biggest area of challenge has been convincing the innovators to adopt the mentality that and really engage in the mentality that the defense industrial base has created. And what I will say is we have broken through that barrier in some really meaningful ways. And an example of that is we're actually using advanced computational fluid dynamics from sort of the space and more advanced portfolio to actually redesign future, condenser systems. And so you start to get into this ability where you can use these more advanced tools in more of a next generation of defense. And so rather than focusing on the current generation and what's been established to date, we're really enabling the value by thinking forward.
Yeah, and having a large portfolio on commercial defense, and it gives you a unique perspective into that by someone that's just making, one specific thing to be able to innovate. Is there, from an innovation perspective, I talked with many companies on this podcast. Historically, the government will give you requirements. You then go meet the requirements. But as we've seen with SpaceX and now, this acceleration of innovation, companies are finding the innovation. Have you found in what you're doing, the government's receptive to your customers, receptive to new innovative ideas? And how challenging is it to get them to even look at it?
Yeah. So I'd say our relationship there started off very slow. You have to sort of work within the confounds of what's been provided to start. And what I mean by that is, here's your technical data package, go build it. And over time, you sort of collect a list of areas where you can improve. Then you build the trust with them that, hey, yes, we're trying our best to execute to the existing structure. And once that trust is built, I'd say that the opportunity just really emerges itself. And so today we're actually redesigning, legacy systems that were designed 30 years ago and have been in production because we built that trust and we've actually run, white papers of what the future could look like and how it benefits. I think that really leads to the second point, which is you got to show how it benefits your end customer. And so if it's, removing a key barrier to obsolescence, if it's a reduction in cost, if it's an improved lead time, it's really relating it back once again to just, business 101, which is bring value to the customer. So I think what we've been able to do is build trust, connect it to value, and then demonstrate through performance that we can bring technology to the defense sector.
That's awesome. And has that, relationship with the customer, because you've been in this, industry for a long time, have you seen that change lately? And I use SpaceX as kind of a stake in the sand. I'm not sure it is, but have you really seen that pivot, or have you always seen that relationship exist?
Yeah, so it's a great question. The immediate answer is absolutely. And the reason why it's undoubted, I was actually at a JANF conference, which is Joint Army Navy, about maybe, I want to say about 6 years ago. And what I noticed during that was there was a panel of national security space folks, and then there was a panel of commercial space. And at the time, it was, we will never use basically a commercial space asset to launch these national security satellites. Today, obviously, that's, NASA's having a hard time even keeping their doors open. And simultaneously, SpaceX, in many regards, is launching a lot of the key portfolios. And what's happening is it's just proving a model for disruption. What I will still say is it's not happening overnight, but it's a slow, methodical move. And the area where I see it most is on entertaining commercially viable options to solve defense-related problems. And so where it used to be, this is a defense solution for a defense problem, we're starting to see, commercial off the shelf be tested and maybe added some robustness, but it meets the base requirements of defense industry. So it's absolutely having a prolific impact.
Yeah, that's interesting. How do you commercialize or make your products be delivered easier? I've seen this in, drones, and we used to build, and we still do, big systems, carrier battle or carrier, an F-35, an F-22, and there's still value in those platforms, let there be no doubt, but it does seem like the ability of grab, something where you've commercialized, a company's commercialized something to make it more modular, potentially scalable. How have you guys fit into that of, being able to take advantage of those opportunities and really accelerate capability sets to the end customer faster?
Yeah, I think it's a twofold answer. The first answer is we've really focused on streamlining our internal capabilities through automation. So we're using, for example, model-based engineering, which basically connects the design environment in 3D to the production environment. And so that's a very, easy linkage. No longer does it create this long, history of paper and drawings. It's a very succinct process. The next is, this advanced multi-phase CFD, as I mentioned, automated welding we're deploying through our factories. So the first answer, I think, is bringing streamlined processes to the operational excellence area. What that allows you to do now is focus on implementing change at the pace that it's actually happening in the real world. So now you have the systems that can be adapted to actually realize the solutions that you're coming up with real time. And so I actually don't know that the pace of coming up with new innovations was the bottleneck. We could come up with ideas very quickly. You can conceptualize them and they can disrupt industries. It was the realization of those that was the hurdle. And so now that we've married together the speed to innovate in terms of conceptualization to now the processes like automated welding and model-based engineering to execute those quickly and realize them, that's been the huge transformation. And so as you look at SpaceX, right, we've linked to it a few times. They're going through iterations on Starship, essentially one a month. That's a massive asset to be doing that on. But they're able to actually create change in a very quick cycle. And so that's what we brought to our business to adopt to that environment.
I mean, there was a time when I was working with another large prime that MBSE or model-based system engineering, it was going to completely break the cost curve. And there's some large projects, not necessarily with who I was with, but way overestimated its efficiency, at least on the cost curve side. I don't know if that's because it's too early in the process. What's your perspective on model-based? I mean, obviously important. It allows you to be much faster, but are we just at the infancy of really maximizing the benefits of that? Or how do you
great
see
question.
that?
I have an opinion on everything, but I'll share one on this. So I think model-based engineering and additive manufacturing sort of go hand in hand. And when I say additive manufacturing, I'm going to specifically say 3D printing. We're at the early phases of both. What they allow you to do, though, is think differently. And they do inherently have efficiency built into them. So automated or 3D printing, for example, you're additively manufacturing something. So it's the most efficient use of material because you're not subtracting from something larger. Model-based engineering, you're not creating an in situ or a work in process set of drawings. You're actually working to the real model. What I think both enable actually is not the streamlining and through WIP, like through the work cycle. I think it's really the feedback cycle on iterations to inform the right system concept is where you get the best benefit. And so, once you get to production, you don't need those. They're not even relevant, both of those solutions. But in the conceptual phase, they allow you to get to the right system architecture quickly. And that's where the biggest benefit comes from. So I think we're in the early adoption phases. I think we'll continue to see that transformation on both of them. And I think what we'll see is a much more efficient concept coming out as a result of them.
So quicker kind of from concept to prototype to get to production, but then that's really where the value add is what
Correct.
Are there any other technologies or advancements in manufacturing? Let's just, digital twin that coined a lot, AI is coined a lot, obviously there's valid use cases for those, but where else do you see is, really opportunities to take manufacturing leaps and bounds, accelerate our capability?
Well, after manufacturing first, and then I want to go to technologies in terms of actual technology. Perfect. Manufacturing, it's an endless list. When you think of, AI just in simplistic terms, I'm just going to use large language models rather than advanced, generative AI in this sense. But the short thing is, you can go through contracts in minutes. You can extract value very quickly. Another example is automated welding. You can repeat the same process on 100 assets, in minutes. I think that all these things are just going to continue to drive towards repeatability, improved reliability, and quality, essentially, which of course adds efficiency. On the technology side is where I get most excited, and I think that there's a few key emerging technologies that are really aligned with the business of Graham, which is cryogenics, really enabling power density. So you think about the ability to cool to, minus 300 F in some cases. You can cool something way more effectively than a forced convection air over let's say a power electronics board. What that allows you to do specifically in space is you can use it as a propellant and a cooling source, which is huge. You have one fluid on one, asset. So I think cryogenics has a key play in just improving or reducing the scale in terms of size and weight. The next one I'll mention is electrification. And we think about electrification in terms of, self-driving vehicles and such. I'm referring to electrification just in terms of, let's say it's a rotating machine like we make. You can have precise control to the, single rotation per minute. And so precision of control, performance optimization, what we're seeing is you're getting these refined algorithms that can essentially control these systems to a level that's never even been imaginable. So very, very precise optimization is what I think we're driving towards with these new technologies. And then the last one is just autonomy. As a result of those sort of things, you can get to autonomous systems. You talked about drones and others. I mean, no doubt, if you don't need a human in the loop for some, rather mundane items, you won't in the future. So
How have you seen workforce requirements change? I mean, workforce is a big deal, and
yeah.
especially in the manufacturing space. Most of my manufacturers are this is passionate. How do you see that environment? How's it changing? I know it's been a challenge. Is it getting better?
Yeah, so I'm deeply passionate about, I'll touch first on the manufacturing side of it. The folks are having to, so we have many skilled machinists and fabricators and welders. The reality is they're having to have not only a hands-on appreciation for the mechanical elements and the physical elements, which is, machining a part and how to approach machining a part, but also they're having to have an understanding of how to interface with the digital environment. So reading drawings, working in Excel, seeing simulations on a computer. We're actually finding, so we started an apprenticeship program here at Barber-Nichols, and at Graham Corporation, we started a welding program, apprenticeship program, and we're seeing a tremendous opportunity for these folks. They're making great pay right out of school. They have a prominent career in front of them for growth. So on the manufacturing side and sort of machinist side, I'd say that there's a struggle, of course. It's not educationally savvy, but we've taken that problem internally to grow that talent. On the more business side, the major transformation we're seeing is you actually have to understand the world at a different pace. And so these automation elements I'm referring to is you don't have the time to think. The systems are thinking as fast as you today. So from a strategic standpoint, if you're used to negotiating material that takes 3 weeks, well, there's systems today that can do it in 3 minutes. And so we're finding that these sort of leaders and engineers have to be able to think at a pace that's augmented with, systems and automation at a rate that's much faster.
So where does that workforce come from? Are you able to, you're doing something internally, but, as I look at like schools and, community college oftentimes as a place, are you seeing the traction that you're able to attract the right talent to, work in that environment?
It's interesting. I've actually been decomposing that problem. So I'm a big believer that you utilize people's strengths. You don't focus on sort of their weaknesses. And what I mean by that is you may have a director of supply chain that understands relationships with key suppliers, and they may understand how the systems interconnect. They understand how to lead and motivate a team through a mission. But they're augmented directly with maybe a buyer that understands the mechanics of a tool set that can automate and build. And so I think it's really this extraction of skill sets and strengths to really form a team that is diverse in skill sets, but together they're really powerful. And so I'm finding less and less single people that can do it all, and more building a team with diversity that can collectively migrate that body of work forward.
I love that. I think that is so true that organizations do better when you focus on the positive attributes of folks. Everyone's got gaps. And if we focus on that, the morale, everything just collapses. So that's fantastic.
Yeah. And in my analogy for our team is in the Super Bowl, when you're on the 1 yard line, you're not putting the quarterback at running back unless they've done it 100 times through the season. You're putting Saquon Barkley back there to finish the game off. So I'm a fan of working on weaknesses and when you're not in the clutch time, but when you are in the Super Bowl and you've earned the entire season to get there, you're putting the best people in the best places to make the outcome the highest probability.
Absolutely. So from the pivoting back a little bit to the, say, supply chain challenges and, supply chain security, and you guys being resilient and reliable for the customers. How has that changed over the last 5 years, and where do you see that going in the future?
Yeah, so I want to acknowledge first that the industrial supply chain specifically for defense has certainly weakened. There's a tribal knowledge portion of it that's evolved over time. There was many folks that obviously from the baby boomers and sort of more senior than that have since exited businesses. And so just, the documentation in small businesses for knowledge has decreased. So we have actually seen a pretty substantial decline in our supply base quality, which is the number one jeopardy, I would say, or risk to just the entire defense industrial base. With that being said, so now let's look forward. What do we do about it? The supply chain, our supply chain at our business they're on our team. And I think the reality is we view them as team members. And so we're extending our resources where we have strengths to help them build on their weaknesses. We're augmenting their weaknesses, maybe with over inspection if quality is a challenge for them. We're deploying manufacturing engineers to help them set up processes so they could be more robust. We're working with the government to actually get funding to create dual sources and or further invest even in our sub-supply chain. So I think it's an approach where they are a part of our team, a part of our mission, and therefore we treat them as an extension and focus on continuous improvement towards the mission. So, long-winded answer for it's a risk. It's one that you have to manage actively. And if you passively just say, hey, they're not on our team, I can tell you you're in a path to failure.
Yeah, I think that's a great approach because just small businesses can't, they can only do so much. And the days of you do it or I'll find someone else are going away. So I think that partnership is super important.
Yeah, and we've had to, openly augment that with vertical integration. In some cases where the supply chain is not stepping up, we've had to either self-invest or, through external means, invest and bring that capability into our portfolio.
Of the advanced technology you're using, is there, I'd say, mineral supply chains or material supply chain concerns that you have? We know China's got access to, the rare earth minerals and many different batteries to different technologies. For you guys, what's impacting you, and are any of those at risk that you're concerned about and need to see us make a change?
Fantastic question. I mean, rare earth materials, of course, only come from the earth in which you own. So that's one that's going to evolve over time. I can specifically call out two. I mentioned the word electrification, which means you need motors, and motors have what's called laminations inside to produce, obviously, the electrification element. Those motors are typically rare earth metals, and they come from very specific mines. And what I'll say is, over time, the demand on those mines has increased. And with geopolitical tensions, that's obviously an ever more competitive landscape. So I'll just say, motors and rare earth metals is one area. The second area is just advanced power electronics. As we get to advanced control, there's very specific components that come from very specific suppliers. And the difference between one vendor to another could be the difference in your product. I mean, it could work versus not work. And so advanced electronics and motors are the two areas where I would say are top of mind.
You mentioned geopolitics. I don't want to necessarily make you pick a side here or anything, but how are the changing politics, that dynamic within our country, and I'd say worldwide, affecting your roadmap, your ability to deliver capability? Are you seeing it change, or is it you guys able to navigate that very seamlessly?
Yeah, so fortunately, regardless of administration, we are very much on the most strategic programs. When you talk submarine and maritime or Navy nuclear, many call it, these programs are in some regards unimpacted by an administration. With that being said, I think it's making us just hyper focused on our internal drive and need to continuously improve and reinvest to keep up with the pace of change. So I don't think structurally it's changing strategic landscape, nor do I think it should, but I think it's allowing us the opportunity to really drive, further efficiencies in our business, further focus on continuous improvement, reinvestment in capital so that we can remain one step ahead. So it's re-emphasizing just some of the key stakeholders in a growth-oriented business.
Great answer. I love it. So if there are folks out there that, want to get into manufacturing, both more on the entry-level side, or as they've got a small manufacturing business and they want to break in the defense sector, what advice would you give, as now, a large aggregator of supply chain and manufacturing? What's your perspective on that?
Yeah, so getting into manufacturing, I'll start there for an employee. The first thing I'd say is go in with an open mindset, ready to learn. there's a lot to learn. And I'd say the thing that we're seeing most successful is the desire to learn, one, and the two, the attention to details. The details matter. They're the differentiator in a manufacturing environment. Anyone can make gee whiz widget. Very few folks can make the refined, precise, where the details matter widget. And so I think the first is going with the learning mindset. Look to build your toolbox, complement your toolbox. A hammer is a lot different than a wrench, just like an additive manufacturing machine is a lot different than a mill. And the more you can put in your toolbox with great understanding, the more leverage you have as you move forward to stay relevant. On the other side of it, so a company that would be considering defense, I would just say really understand the architecture of what defense requires before diving in. A job shop pivoting from automotive to defense, it comes with cybersecurity requirements. It comes with federal acquisition, requirement flowdowns. It comes with international trade requirements. And so the point there being is it comes with an extensive amount of not just machining the part requirements. And without understanding those, you can get yourself into a very challenging situation quickly.
Absolutely. And not super easy to work with the government, but super important, obviously.
Yeah. And the advantage of it, just to offset the, caution, is you can have long-standing, very long-term contracts that allow you to reinvest in your business and make smart, long vision decisions, which is a big enabler.
But where do you think the biggest growth opportunity for Graham is in the defense, area and commercial, both sides?
Yeah, this is the one that obviously most excites me. The world's a big place. Graham has a global footprint. I think our products have great need in every spot in the world. And we're just tapping into that new opportunity. So just breadth and magnitude of deployment of technology is the first one. The second one is disrupting existing and future markets with just technology. We've got Barbara Nichols, who is designing the most power dense fluid propulsion systems for launch vehicles that can bring some amazing technology to a very established, one, defense environment, and two, legacy vacuum and heat transfer environment. So I'll just say the ability to disruptively innovate. I'll keep it high level.
Exciting. Yeah, I love disruption for the better good.
Yeah. No, it's
not disrupting for disrupting's sakes. But so how about are there any big projects or partnerships or tech investments, that get you on that road that you're excited about right now?
I think I'll cap off just with a good story, because I think it's always good to have a story. And maybe this is what really defines me as a person. So early in your career is where you take some of the biggest knocks. And my time at GE, it is a global business. We're shipping locomotives all over the world. And we had just launched a new Evolution Series locomotive to basically all reaches of the world, one of them being Indonesia. We had landed 26 locomotives, which were vital not only for resource movement and moving critical equipment, but during holiday seasons actually moved the majority of the country. So they went from passenger to freight and vice versa. And these turbochargers, we had shipped, a bunch of locomotives, 26 had failed in about 2 weeks. And I'm on the phone, I'm 27 years old. I'd been in front of a lot of customers with a lot of big problems, but this one sort of surpassed them all. And it's 26 locomotives that aren't working in 2 weeks. They're coming up on their major holiday season. The president in the country is actually getting threatened, frankly, for his life. And I'm in charge of designing the turbochargers with my team of 8 to solve the problem in what is 3 weeks before the major holiday rush happens. And the key takeaway that I had from that moment was what's formed my entire leadership style. The first is those moments you have to get back to the basics, which in a technical environment is the physics. And so simplifying the problem down to the physics and understanding the root cause is what prevails. And so we were able to do that within days, which is a huge enabler. The second is putting the strengths in the right places when you most need it. Those are the moments when you have to know your people the best so that you could rapidly deploy people to their strengths almost immediately. The result of that whole situation was an 11-cent little shim that went under the turbine blades on the turbocharger that we were able to deploy within literally 3 weeks and resolve this entire high slug fatigue problem in the country. And my point being is it brought forth these very two key foundational elements. The first is dive into the physics to understand root cause when you have a challenge, just like basic problem solving. And the second was you need to know the strengths of your team so that when the challenges come, you're ready to deploy in full force. And so that has shaped me today. I think it shaped Barber-Nichols and now will shape Graham. So
that is a great story.
Yeah, it's one that raises the hair on my neck because we almost lost an $8 billion contract on the energy side as a result of the locomotive. So it's one of those tattoos that you artificially live with.
Yeah. I mean, what a defining moment, right?
Yeah.
Everyone needs one of those, like horrible challenge or very difficult challenge, and to come through it and the confidence that brings, like, okay, this stuff works. What a great leadership moment for you.
Yeah. Thank you.
I'll give you one more question before we wrap it up. But because we're talking a lot of technology innovation, manufacturing innovation, the next decade, is there a capability or technology you think, leaders are missing that they ought to put back on their radar or focus a little bit more on?
Yeah. So this is an interesting one. And my answer is going to be very unique. I believe that many leaders today underappreciate the criticality by which the systems behind the scenes that run the business. So an example of that today is we had focused on turbo machinery for a long, long time. And we got pretty good at turbo machinery, rotating machines. The core infrastructure, which enables all the 200 people across Barber-Nichols and 350 across Graham to interface, interact, solve problems, is the IT infrastructure behind it. And we had zero understanding of that infrastructure. But it's become the number one enabler that we've reinvested in to propel us forward. And so I think the advice that I would give is just having a holistic view of both the risks and opportunities and making sure that those are balanced at any given time is the number one thing that I think folks are missing. I think we either get too risk-oriented or too opportunity-oriented, and we start missing the entire risk framework. And an example of that I'm using was we got so focused on opportunity and growth and prosperity that we had lost the biggest risk, which was, IT infrastructure. And so mapping it all kind of together, it's just that balanced approach to leadership and really understanding the two sides of the coin with risk and opportunity.
That's a unique answer, but I love it though. Yeah, because it's tough too, because a lot of those enabling systems, the technology is changing quick now too. So if you're stuck in your rut, your IT system is working now, we're good, but you're not paying attention to it as technologies change, threats change. You also fall behind, and the pain to change it's ridiculous.
One other addition to that is one of my key principles is force multiply. And what that means is if you're one leader up top, you really need to engage the entire troops below. That's where the power comes from. And if you don't think in a framework that enables them to maximize their potential, then you're not moving forward. So for one person to have one thought, it could be the best thought ever. But if you can multiply that by 200 people that are working under that framework and they're enabled through, in this example, systems or career path growth model or whatever it might be, if you can get the reach of those 200 people, or in some cases 100,000 employees, that's when the magic happens.
Fantastic. Well, Matt, I love this. I mean, I've learned a lot. I think you've, shown an amazing aptitude for leadership, coming through, your career journey that is notable and commendable. So
thank you.
Done.
The people inspire me to do it.
Yeah, I look forward to watching, Graham Corporation and your subsidiaries continue to kick butt. It'll be fun to watch. But if folks want to follow you or get in touch with you to talk about opportunities or partnerships, how best to do that?
Yeah, I think LinkedIn is probably the easiest. You start giving out emails and everything else, and it can get astray. But one of the things that I'd offer is there's a team behind it, right? There's a whole host of Graham Barber-Nichols employees, P3 employees that make it tick. And I would just say they're an extension of the vision. So it's not just me. Reaching out to them, engaging the subsidiaries as mentioned is a fantastic way to nurture this forward.
Fantastic. Well, thanks, Matt. Really enjoyed this. And since you're a fellow Boulderite, we'll connect one afternoon.
Perfect.
It'll be fun.
Right up the hill from you. I can see out your back window, so I know where you're sitting.
That's right. All right. Well, thank you, sir. Appreciate it.
Thanks. Take care.